Here's a problem that's a little bit more involved, but does still use the sum formula. So we're asked to find the sine of alpha plus beta. So if we write down what our sum formula says, we've got sine of alpha times cosine of beta plus cosine of alpha times sine of beta. And some of these were given to us. Let's fill in what we have. Sine of alpha is 3/5. Cosine of beta is 5/13. We don't know cosine of alpha yet. We'll find it in a minute. And we don't know sine of beta yet, but again, we'll find those. Now to find each one of these, let's see if we can find first cosine of alpha. And this really comes from an earlier chapter. If you have sine of alpha and the quadrant that the angle is in, you can use the Pythagorean identity. Sine squared of alpha plus cosine squared of alpha has to equal 1. We know that sine of alpha is 3/5. So you have 3/5 squared plus cosine squared of alpha equals 1. So if you want, pause the video, see if you can find cosine of alpha, and then do the same thing over here to find sine of beta, and then you can take a peek. Here's a common mistake to watch out for. When you square root both sides, when you have cosine squared of alpha equals 16/25, remember that when you square root both sides, you get a positive and a negative answer. Now, cosine is an x value. It can't be both of those at the same time. But if we remember that alpha is in quadrant 2, then we know that cosine of alpha equals -4/5. So let's grab this value and hang on to it. We'll put it back into our equation in just a minute. And then try finding sine of beta, also using the Pythagorean identity. So similarly, we use the Pythagorean identity to find sine of beta because we know cosine of beta. Watch out at the end there. When you take the square root of both sides, you get a plus and a minus. We know that beta is in quadrant 4, so that's how we know that the sine of beta is -12/13. All right, so why did we need this? Because if we look back, if we look back to where we were up here, we only had some of our terms. All right, so we have 3/5 times 5/13 plus cosine of alpha, but that's negative, so -4/5 times -12/13. Let's take a second to clean that up and simplify. So we have 15/65 plus 48/65. So we have 63/65. So this is what sine of alpha plus beta equals. So just to review, because there's a lot of steps to this problem, we started with our sum formula, and that has 4 pieces in it, right? Sine times cosine plus cosine times sine of those various angles. We knew 2 of those pieces given in the problem. We had to find the other 2. But when you have either sine or cosine and the quadrant the angle's in, you can find the other one.